So for the do now, what you have to do is find the volume of this cylinder right here. And for our purposes, let's say round to the nearest tenth. So pause your video now so you have a chance to complete that. Okay, so you guys should have already answered, so you should already know the answer to this. The volume of cylinder is, of course, pi times the radius squared. We're given the times the height. We're given the diameter and the height. So to find the radius, of course, we want to split the diameter in half. So the radius would be 10 meters. So let's just plug some stuff in. We have pi times 10 squared times the height of 13. Calculator time. You should end up getting about 4,084.1 cubic meters. So what we're going to do these next 2 days is look at density type problems. So usually you have to model the problem using some sort of volume formula, most likely. And then after that, you're going to have to convert some units to figure out a new thing. So instead of the volume is cubic meters, you'll be like, this holds 300 pounds worth of blank. So basically we're taking what we did Monday and Tuesday, putting it together, and that gives you what we do Wednesday and Thursday. So this problem here says the volume of an oil tanker is 50 liters. The density of oil is 0.93 grams per cubic centimeter. And if the oil tanker is completely filled with oil, what is the weight of oil in grams? So, real important here. What we're looking for is we want the weight of oil, and our answer should be in grams. Now what we're doing is we're starting with liters. And we have a conversion ratio that goes from centimeters cubed to what we're looking for in the end, grams. So what we're missing here, basically the way we're going to do this is, so first we're going to need to go from liters to centimeters cubed. Then we're going to go from centimeters cubed to grams. And then that's our final answer. So what we're going to want here is you're going to want the reference sheet, which I posted on Google Classroom. And you guys should have already made a copy of it and saved it, something like that. Because on the reference sheet, it shows you the liters to centimeters cubed conversion. It says that 1,000 centimeters cubed equals 1 liter. So we're going to use that to convert our 50 liters into cubic centimeters. So we're going to do the same thing we did during the unit conversion lesson. We're going to start with 1,000 cubic centimeters over 1 liter equals, and then we have cubic centimeters here, and we have liters here. We're starting with liters. We have 50 liters to start, and we have X cubic centimeters. So right here, you're just going to cross multiply. You're going to get X equals 50 times 1,000 is, oh, hey, guess what? 50,000 centimeters cubed. And now we're going to use that, the 50,000 cubic centimeters, and we're going to use this conversion ratio right here to go to grams. So using the conversion ratio, we have 0.93 grams per centimeters cubed, which means per 1 centimeter cubed. And then that should equal some number of grams, which is what we're looking for as our final answer, over the 50,000 centimeters cubed. And all you have to do to solve this problem is cross multiply. You get X equals, calculator, you get 46,500 grams. Now, this was a slightly easy example, and the reason it was easy is because they already gave you the volume. Now, sometimes on more complicated problems, you're first going to have to find the volume and then go through this. These problems can become pretty hefty. That's why I only gave you 2 of them today, and I think there's only 2 tomorrow. So just take your time. These are not meant to be finished in 25 seconds. These are going to take you a few minutes, 5-10 minutes each most likely. So basically what you want to do, figure out what you're starting with, what you need to finish with, and then try to find stuff along the way that can help you get there. And don't forget, your reference sheet has a lot of important ones. Like this one right here was very subtle. It went from liters to centimeters cubed. Like you can't go liters straight to grams because we don't have anything that goes liters straight to grams. But we do on the reference sheet have something that goes from liters to cubic centimeters. So make sure to check that and see if that can fill in some missing steps that you have. And after you finish the worksheet, you just have to answer the question, the reflection question that says, explain how density problems combine what we've been learning this week, how it combines modeling problems, and how it combines unit conversion. And don't forget that your Delta Math is due Friday at the beginning of class.